Hello class, welcome to the next lesson in 8th grade Eureka Math. We're in Module 4, Lesson 19, which I'm calling Graphing with Intercepts. Today we're going to learn another way to graph a linear equation. In the last lesson, you graphed a linear equation using slope-intercept form. You found the y-intercept, you put a point. You follow the slope rule, you put another point, and then you connected the points to make the line. Well, that is how you graph with slope-intercept form. Today, you're going to graph out of standard form using intercepts, using the x and the y-intercepts. In slope-intercept form, you graphed using the y-intercept and the slope rule, but you can graph today by just finding both intercepts. And so that's why our vocabulary words today are x-intercept and y-intercept. The x-intercept is the point where a graph crosses the x-axis, the point where it crosses the x-axis. The y-intercept is the point where a graph crosses the y-axis. So you can see the x-intercept is a point and the y-intercept is a point. And if we connect 2 points, we make a line. So if we find this point and find this point and connect them, you will see the line. So that's how we're going to graph a line today. So the biggest thing today is, how do you find the x-intercept? How do you find the y-intercept? So copy down those vocabulary terms because they are important for you to internalize and memorize. Again, as a reminder, if you ever need to pause the video to catch up in your notes or go back and rewatch something, that is perfectly okay. You are in control of the speed of the video. You are in control of going back or pausing. Just do it whenever you have to. Today, what we'll be doing is we'll review how to graph linear equations in slope-intercept form. So we're going to get a little bit more practice graphing in slope-intercept like you did in Lesson 18. But also today we're going to learn how to use both intercepts, x and y, to graph from standard form. Because we don't always get equations in slope-intercept form. Sometimes equations are written in standard form. So you need to know how to graph those also. So that's what we're doing today. We're going to learn another way to graph. You know how to graph using the y-intercept and the slope rule. Today, you're going to learn how to graph using 2 intercept points. So a couple of notes I want to put down right here. We skipped some pages in this lesson. We did skip some. Like we are starting on page 233. I forget what page the lesson started on. I think it was like 227 or something like that. But we did skip some pages in this lesson. I want to skip the pages and not do the work, but I want you to know the ideas that were in the pages. I have referred to them before. That's why I felt comfortable skipping those lessons. The idea that was in those pages we skipped, the big idea was that a linear equation graphs to a line, and a line represents a linear equation. In other words, a linear equation is a line, and a line has a linear equation. A linear equation makes a line, and a line has a linear equation. That was the big idea for the pages we skipped, that linear equations and lines are connected. That was the big idea. We have talked about that before in our lessons, so I feel that we are comfortable skipping the pages where they reviewed it. I just want you to write this down in your notes. The linear equation and line go back and forth. They are connected. But let's move on to actually just practice some graphing using standard form and intercepts. I'm going to say x-intercept and y-intercept a lot in this lesson. Make sure you understand the vocabulary. X-intercept is a point where a line hits the x-axis, and y-intercept is the point where a line hits the y-axis. But let's look at an example of this. I did my example on some graph paper. Now you can either copy my example, or you can print it out from the online notes on the Google Classroom, or you can just look at it and follow along. So the question is in the black, graph the equation 2x plus 3y equals 9. 2x plus 3y equals 9. We want to graph that. But this is not in slope-intercept form. What do we do? In lesson 18, you learned how to graph with slope-intercept, but this is not slope-intercept. What do we do? Well, I know that we are graphing a line. This is a linear equation because the variables have only a 1 or a 0 as an exponent. So this is linear. And to graph a line, we need 2 points. Remember, that's how we graphed with slope-intercept. You found the intercept, you follow the slope rule to make another point, and then you connected the points. So a line needs 2 points. Well, if this is our equation, and we need 2 points, we can use the x-intercept and the y-intercept for the points. So because we know we need 2 points, let's use the x-intercept point, and let's use the y-intercept point. Now, here's a reminder of the vocabulary. The x-intercept is when y is 0. It hits x, the x-axis, when it hits the x-axis is when y is 0. So the x-intercept is the point, comma, 0. The y-intercept is when x is 0. So this is the definition of the intercept. In fact, you remember this when we talk about the y-intercept in lesson 18, because this looks similar. When we talk about the y-intercept in slope-intercept form, we said it was 0, comma, b. So that is familiar because the y-intercept is b. You remember that from lessons 15, 16, 17, and 18. Y-intercept is b, and the x is 0. So the y-intercept, x is 0. And the x-intercept is opposite when the y is 0. So we can use this knowledge. X-intercept means y is 0. Y-intercept means x is 0 to find our points, which is what I did down here. Excuse me. So x-intercept is when y is 0. So I take my equation right here. This is my equation. Step 1, find the x-intercept. So x-intercept means y is 0. So I take 0 and put it where y is. Instead of y, I have a 0, and I solve it. I solve it. So y is 0, which means 3 times 0 is 0. That gives me 2x equals 9. Divide both sides by 2 with the division property of equality. I get x equals 9 divided by 2. So if y is 0, x is 9 over 2. Which means I can turn those into coordinates that look like this. 9 over 2, comma, 0, because y is 0. And in the equation, y0 means x is 9 over 2. Or you can say 4.5 and 0. So the x-intercept point is right here. Because I know x-intercept, the y is 0, 0, 0. And then I substitute and solve to find the x. I do the same thing with the y-intercept, except for this time, x is 0. So x is 0. So in my coordinates, the x is a 0. And I use x is 0 in my equation. So wherever I see x, I put a 0. And then I solve it. I get 0 plus 3y equals 9. I get 3y equals 9. Divide both sides by 3 with the division property of equality. Y equals 3. So x is 0. Y is 3. So this is the x-intercept, and this is the y-intercept. I did them both because I knew they happened when y is 0 and x is 0. So these are the points where they cross the lines. I have the x-intercept and the y-intercept. Step 1, find the x-intercept. Step 2, find the y-intercept. Step 3, down here, graph the points and connect them. So the y-intercept, well, x-intercept was first. So we do 4.5x and 0y, which is right here. There's the x-intercept. The y-intercept is 0x, 3y, 0x, 3y. So the y-intercept is right here. So I graph the x-intercept down here. You see is red, just like our writing. The y-intercept is blue, just like our writing. We have 2 points now. We connect the 2 points, and that's how we graph a line. So we can use intercepts to graph a line. So this is a little summary. This is what you might want to add to your notes right here. How to graph from standard form. So if you have standard form, you graph step 1, find the X-intercept. Step 2, find the Y-intercept. Step 3, graph the points and connect. Graph the points and connect. So that example should help you, but let's do a few more exercises together. Following the same exact strategy, we're going to find the X-intercept, find the Y-intercept, and then graph and connect. So let's do this. Let's go to page 233, where we have exercise 9, 10, and 11. We skipped exercise 1 through 8, remember? So page 233, exercise 9, says graph the equation -3x plus 8y equals 24. So this is our equation, and they want us to graph it using intercepts. So let's start step 1, find the X-intercept. Well, we know for the X-intercept. The X-intercept is when y equals 0. This is how we find the X-intercept. We make y 0. So we write the equation, except that when we see y is 0. So we get -3x plus 8 times 0 equals 24. That gives us -3x plus 0 equals 24, which is just -3x equals 24. Division property of equality tells me I divide by -3. -3x divided by -3 is 1x. 24 divided by -3 is -8. So the X-intercept, y is 0, x is -8. So the X-intercept point, x is -8, y is 0. That's step 1. I have the X-intercept. Step 2, I need to find the Y-intercept. The Y-intercept, remember, is when x is 0. So now I'm going to solve the equation again, except for this time, when I have the x, I'm going to put 0. So -3 times 0 is 0. 0 plus 8y equals 24, which is 8y equals 24. Division property of equality, divide by 8. 8y divided by 8 is 1y. 24 divided by 8 is 3. So that point, x was 0, y is 3. That's my Y-intercept. So I have the X-intercept where the line crosses the x. I have the Y-intercept where the line crosses the y. That's step 1. That's step 2. Step 3 is to graph them. So now I need to get some graph paper, and I'm actually going to graph these 2 points on a set of axes, connect them, and that will show me what the line is. So grab yourself some graph paper. Mine looks like this. And we're going to graph these 2. Let me put the 2 points on the screen, and let me put my graph paper on the screen. And we're working on our exercises. And this is exercise 9. So I need to go -8x to 0, and I need to go -8x to 0x and 0 to 3. So I need to probably go this way. Practicing making your graphing is super important. So that's where my axes need to be. Let me label my, here's my y-axis, here's my x-axis, there's my origin, 0, 0. There's 1x, there's -1y, 1, 2, 3, 4y, -1, -2, -3, -4, -5, -6, -7, -8, -9x. Okay, now I graph my points. So the X-intercept, the line crosses at -8, 0, which is right here. That's where the line crosses the x-axis. The y-intercept, where the line crosses the y-axis, is 0x and 3y. It goes right there. So I have the x-axis, the x-intercept, the y-intercept. I have 2 points. And if I want to make a line, all I do is I connect my points. I'm going to be as careful as I can. Make sure I be as accurate as possible. And there is my line. So that line is right here, negative 3x plus 8y equals 24. That is the graph for the equation. And that's how you graph it. You find the x-intercept, you find the y-intercept, you graph the 2 points, and connecting the 2 points makes the line you need. That's exactly what we're doing today. We're graphing using intercepts. So in lesson 18, you graphed using 1 intercept and a slope rule. Today, you're graphing using 2 intercepts. Let's do number 10 together, and then I'm going to ask you to do number 11 on your own. But number 10, we have this equation, x minus 6y equals 15, and we need to use intercepts. So again, let's find the x-intercept first. And remember, the x-intercept is when y equals 0. So you take the equation that we have up here, only instead of y, we put a 0. That gives us x minus 0 equals 15, which means x equals 15. So the coordinates for the x-intercept, x is 15 and y is 0. That's the x-intercept right here. X-intercept is 15, 0. Step 2, find the y-intercept. The y-intercept is when x equals 0. So I take the same equation and I put x as 0. I put 0 for x. X minus 6y equals 15. Now this gives me negative 6y because 0 minus 6y is negative 6y equals 15. Then I need to divide by negative 6 on both sides for the division property of equality. Negative 6y divided by negative 6 is 1y. 15 divided by negative 6. Negative 15 over 6, which simplifies because 15 and 6 both have a factor of 3 inside of them. I get negative 5 over 2. Negative 5 over 2 is negative 2.5. You might have solved this using a calculator, but negative 5 divided by 2 is negative 2.5. So the coordinates for the x-intercept, x is 0, and y is negative 2.5. That are our 2 coordinates. That's step 1 and step 2. We have the x-intercept, we have the y-intercept. This is where the line crosses the x. This is where the line crosses the y. Now to make the line, we graph these and connect them. So let me get my graph paper back. And let me get my let me label number 10, still on the exercises. And just to help out, and just so you can see, I'm going to write my intercepts here. X-intercept is 15, 0. That's what it says on this paper right here. I'm just adding it to my graph paper so that you can still see it. And the y-intercept was 0 and negative 2.5 or negative 2.5. Now I need to graph those. I have my intercepts. Let's graph them. So now I need to build my axes. Now x needs to go all the way to 15. Y needs to go to negative 2.5. So I'm probably going to go like that. And I need to go out at least to 15. I'm going to go a little bit more. There's my axes. There's my y-axis. There's my x-axis. There's my origin at 0, 0. Now I'm labeling my intervals. I'm sorry, that's -1, -2, -3, -4. Label my x intervals to make a complete and accurate graph. And once you get good at making these graphs, it goes really fast, like I'm done right there. Now I'm able to put my points. So my x-intercept is 15x, 0y, which is it crosses the x-axis right there. My green dot. The y-intercept is 0 and -2.5. So 0, and then I go down 2.5. So it's going to go right there, halfway between -2 and -3. Now, to make my line, I just connect the x-intercept where it crosses the x, the y-intercept where it crosses the y. I connect them, being careful to go through the center of both points to keep accuracy. And there is the line I graph. So that is the line for this equation. The equation was x minus 6y equals 15. And that's the graph. It goes really fast once you know how to, once you're good at finding the x-intercept, good at finding the y-intercept, you can graph it pretty quickly. You can graph it pretty quickly. It does take practice, but you can do it. You can see, you just, step 1, find the x-intercept. Step 2, find the y-intercept. Step 3, you graph them and connect them. There's how you graph. What I'd like you to do on your own right now, the last exercise is exercise 11. We have another equation. We have the equation 4x plus 3y equals 21. I would like you to do all the work yourself right now. So pause the video, try it yourself, and graph it. Find the x-intercept yourself, find the y-intercept yourself, graph it yourself, and then when you're all done, come back, unpause the video, and check your work with mine. Okay, so hopefully you pause the video, you did number 11 on your own, and you're ready to check your work. Here, this is what you should have done. This is the answers you should have gotten. So you should start with step 1, find the x-intercept. And you know the x-intercept is when y is 0. So you take the equation, and instead of 3y, you put 3 times 0. That gives us 4x plus 0 equals 21, which is 4x equals 21, which is x is 21 over 4, which is a little bit complicated. But you can, if you use a calculator and you divide this, you get this is 21 over 4, which is 5 1/4, or you get 5.25. All of these are the same thing. 21 divided by 4 is 5 1/4. I change it into a fraction to make it easier for graphing. So we change this into coordinates. X is 5 1/4, and y was 0. That was step 1. That is your x-intercept right there. For your y-intercept, this is what you should have done for y-intercept. For y-intercept is when x is 0. So you take the equation, except instead of the 4x, you put 4 times 0, plus 3y equals 21. So 0 plus 3y equals 21. Gives me 3y equals 21. So y is going to be 7, because 3y divided by 3 is 1y. 21 divided by 3 is 7. So the coordinates, x is 0, y is 7. That is your y-intercept. So now you have your x-intercept, you have your y-intercept. Those are the coordinates you should have gotten. If you did not get those coordinates, go back and check your work, see what you did differently than me, and fix it. But if you got those coordinates, then you are ready to graph. So let me write the coordinates again on my graph. This time is exercise 11. So my x-intercept, the coordinates I got were 5 1/4 and 0 for the x-intercept. And for the y-intercept, you got x is 0, y is 7. So those are your two coordinates. Sorry, paper's getting moved around a little bit. Now we are ready to graph. So x needs to go up to 5 1/4. Y needs to go up to 7. So let's graph. There we go. And x is 5 1/4. Let's see. I'll show you. Let's change our intervals a little bit. And because 1/4 is kind of small, it might be hard to see. What we're going to do is this. Let me show you something. Okay, you can see I made my graph maybe longer than yours. Here's my origin. This is still my y-axis. This is still my x-axis. -1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see my y-axis looks pretty normal. It looks pretty standard to what I've been doing. What I'm going to do for the x-axis, though, to make this a little bit clearer to see, instead of counting by ones, I'm going to count by something else. And you have to remember that you are in control of making your graph. So you control whatever you want to count by. In number 9, we counted by ones everywhere. In number 10, we counted by ones everywhere. But in number 11, I'm going to count by 1/4. 1/4, 1/2, 3/4, 1. 1 1/4, 1 1/2, 1 3/4, 2. 2 1/4, 2 1/2, 2 3/4, 3. 3 1/4, 3 1/2, 3 3/4, 4. 4 1/4, 4 1/2, 4 3/4, 5. 5 1/4, 5 1/2, 5 3/4, and this one would be 6. You can see I chose not to count by ones. Now, you could have counted by ones if you wanted. If you did count by ones, then you're just putting your point somewhere in the middle of the blue lines. That's perfectly fine. You make your own graph. You choose whatever you want to count by. You are in charge. I just counted by 1/4 to show you that you can do something a little bit different. And to also, because I saw this was 5 1/4 and 0, it lets me put my purple point, my x-intercept, on a blue intersection with the blue lines. And so I kind of like to do that because then I get, and it looks more exact to me. So this is my x-intercept at 5 1/4 and 0. My y-intercept is at 0 and 7 up here. So I have my two intercepts. Now I connect them to finish my line. Connecting them should go like that. And that is my graph. That shows me that is the equation 4x plus 3y equals 21. Now, I did tell you now this is what your graph would look like if you used 1/4 intervals. Let me show you real quick maybe what your graph looks like if you counted by ones. If you counted by ones, let me show you what your graph might look like just if you're curious. So if you counted by ones, this is probably close to what you drew. So your 5 1/4 is going to be about right there. You notice how I have to go kind of 1/4 of the way between 5 and 6. 0, 7 is still on the line right there. And so when you graph them, when you connected them, I mean, you probably got this. So if you counted by ones, this is what your graph will look like. If your intervals counted by ones, this is what your graph look like. But so this is one right. Both of these are right. This is what the graph looks like when the x intervals are 1. This is what the graph looks like when the x intervals are 1/4. So this is right and this is right. They both have the same intercepts. This is just wider because I made my intervals smaller. But if checking your work right now, checking your work for number 11, I'm guessing your work looks like this one. If your work looks like this one, you are correct. I just did this one to show you something different. They both are the same line. It's just the intervals that made it look a little bit different. But that's number 11. Hopefully you got it right. Hopefully you graphed it. Hopefully you found the right intercepts. You found the X-intercept. You found the Y-intercept. You graphed them and connected them. Hopefully you did all that. You understand what you're doing, and you're ready to go try the problem set. So let's look at what we're doing today. So this is the lesson summary on page 234. You can see that they give you the example. You can graph a linear equation. You can be graphed using 2 points, the X-intercept and the Y-intercept. So this is right here. They tell you how to do it. They give you another example. This is where they find the Y-intercept. This right here, they find the X-intercept. And I told you to find the X first. They found the Y first. It really doesn't matter which one you do first. So this is like step 1. This is step 2. But it does not matter which one you do first. You can switch them if you want. But step 3 is always the same. Step 3 is graph and connect. So the lesson summary is exactly what I gave you in the little corner of my example. How to graph, find the X-intercept, find the Y-intercept, graph points, and connect. That's the lesson summary right there. Just a little bit shorter than page 234. After page 234, you'll see page 235, which is the exit ticket. Don't worry about that right now. We'll shuffle that to the end, and the exit tickets actually continues on page 236. So take both pages, put them in the back. If you would like some more examples about how to graph with intercepts, look at the homework helper on page 237 and 238. 237 and 238 have looks like 4 examples about graphing with intercepts. And then we get lesson 19, problem set, which is 10 graphing problems. Now you'll notice I do have some extra instructions on the left side right here, because this is practice for both lesson 18 and lesson 19. Because you will see, like for number 1, graph this equation. Well, this equation is in slope-intercept form. So you have the slope, you have the intercept. So you're going to use lesson 18 skills to graph this. You're going to start with the intercept, follow the slope rule, and then graph it. Connect the points. So number 1 is going to be what you learned in lesson 18. Number 2, this is in standard form. So use the intercepts. Use today's lesson 19. Number 3, this is slope-intercept form. So use lesson 18 skills. Number 4, that's lesson 18 skills because it's slope-intercept form. Number 5, that's standard form. So use today's lesson 19, find the intercepts. Number 6, standard form again. So use intercepts like today in lesson 19. Number 7 and 8, you're going to need lesson 14 because these y equals 3, x equals -4. These are horizontal or vertical lines. You have to tell you're going to graph these and tell me what the slope is of these lines. So you might need to go back and look at your notes for lesson 14 for number 7 and 8, because these are not sloped lines. These are horizontal and vertical. So if you need to go back and look at lesson 14 to help you think about 7 and 8, do that. Number 9 and 10 are asking you, are those equations graphs for lines? Do those equations make lines? For that, you might need to go back to lesson 2 and find out and remember, how do you know if equation is linear? How do you know if an equation is linear? Make a line. Well, here's a hint back from lesson 2. It's all you have to look at the exponents. The exponents will tell you if an equation is linear. So you need to go back and think about what exponents I'm talking about, and how do you know, how do the exponents show you linear or not linear? So knowing if these are linear, if they make a line, lesson 2 will help you with that. But that's a problem set, the 10 questions on the problem set. My answers to these 10, my graphs for these 10 are on the Google Classroom, so you can check your work with mine. Make sure you have the right answers. If you do not get the right answers, you can always reach out to me and we can have a little meeting and I can talk to you about your work and see what I can help you with. But you have to ask. Send me an email if you need some help. I'm happy to help. Just reach out and ask. But after you do the problem set and after you check your answers with mine and you feel confident, then you are probably ready for the exit ticket for today's lesson 19. Now there are 3 questions on the exit ticket. Question 1 wants you to graph this equation. Now, if you look at the equation, you should see that that is in slope-intercept form. So you need to use the y-intercept and the slope to graph this. That's lesson 18 skills. So use lesson 18 skills to graph this on there, and they already gave you room to make the graph. To practice lesson 19, to practice today's skills, look at number 2. This equation is in standard form. So standard form, find the x-intercept, find the y-intercept, graph, and connect. So for number 1, you're going to practice lesson 18 skills. Number 2, you're going to practice what we learned today in lesson 19. And for number 3, what do you know about those 2 equations? If you look, this equation was for number 1. This equation was for number 2. So what can you conclude? What can you figure out about the equation in number 1 and the equation in number 2? How are those equations connected? This was the equation from number 1. This is the equation for number 2. How are they connected? Explain that to me for number 3. And that's your exit ticket. Remember, take a picture of your exit ticket, turn it into the Google Classroom assignment so I can see you understand how to graph using slope-intercept form and how to graph using standard form. Remember, if you have any questions, reach out to me. But have fun, do your best, work hard, and I will see you for the next lesson.